Hello and welcome to Technical Utkranti. And today we'll do a new question and let's see what is it. So this is the 10th question in our array series. Let's understand the question first. We are given an array of length n plus 1 which can only have elements from 1 to n. So there definitely would be one repeated element, but the condition or the information given over here is that the repeated element would be only one. So there would be only one repeated element, but that could be repeated many times. So an array of length n plus 1 will have elements from 1 to n, and there would be at least, there would be exactly one repeated number, and its repetition could be many, right? So for example, in this array you can see that 9 is the number that is repeated. So 9 is the only number that is repeated, okay, and it is there 3 times. So this is an array of length 10. So 10 is n plus 1, which means that it could have numbers ranging from 1 to 9, and one of this number would be repeated, and we have to find the repeated number given the array. So this is the question. Let's see how are we going to do it. The first approach is to sort the array and then traverse the array, and if the subsequent elements are found to be same, then that is the repeated number. But sorting of the array is done in O of n log n time complexity. So we can have a better solution than this. Okay. Let's see the second approach. The second approach is having a frequency map for the array. So what we'll do is we'll have an array of zeros of these same, of length n, right? Because we'll have only elements from 1 to n. Now, whatever element we'll traverse on this array and whatever element we encounter, that index we incremented by 1. Okay. For example, 2 we found 2, so second index 0 1 2 is incremented by 1. Similarly 4, then 9, 6 and 9. So as we like find an find an element, uh, and the index in this array is already 1, then we know that this is the repeated element. So we return the corresponding element. Here time complexity has improved, all right, but the space complexity over here is O of n, right? So the question demands that the solution should be solution should be found in fixed space, extra space complexity. So this particular solution uh, answers the question. Let's see the implementation in Python. So what we do is we have an array of length n plus 1. So we find n, which is 1 less than the length of the array, and we create an array of zeros or the list of zeros of length n. Then we traverse on the array, and whatever element we encounter, the index of it is incremented by 1 if it is 0 previously, and if it is not 0, like in the else part, we have found the element and we'll return it. So the same input I have given as I have shown in the PPT. Let's see what we get. So we get the solution 9. All right. Okay. Now let's see the third and the more interesting approach, which is tortoise hare approach. Here we use a slow pointer and a fast pointer. So slow pointer moves one step at a time, whereas the fast pointer moves 2 steps at a time. All right. So before understanding the actual solution, let's understand one important concept over here. So for example, let's consider a cycle of 4 points. All right. Now, if slow and fast pointer starts from a particular point and slow moves one point at a time, right, and fast moves 2 point at a time, 2 points at a time, then the distance covered by the fast pointer would be twice the distance covered by the slow pointer at any instance, right? So as you can see that after first instance S is here and F is here. At the second instance, F has covered one cycle because it was just 4 steps long, and slow has covered half of it, right? And then S comes here, F again comes here, and then S and F again meets at this particular point. All right. So we can see that S and F meet at the same point from where they have started in a cycle, wherein F has covered twice this cycle and S has covered this cycle just once. The other way of understanding this is that S has to take, let's say, A hops to come back to this point. In that time, F would have taken 2A hops, right? And it would have come over here. So the point where they started, they will again meet at that point. This is an important concept to understand. Now, let's say that S and F entered into this cycle one step behind this. So S comma F started from here. Then in one hop, S comes here and F is over here. This is the exact position where they would have reached had they started from here. Correct? Which means that if they start S and F start from here, then they will meet over here, right? They will meet over here at this point. Similarly, if S comma F starts x points earlier than this point, then they will meet x points earlier in the cycle. This is a very important concept to understand the solution. Now let's get back to the solution. So we have made this cycle. How we have made this cycle? We have made this cycle following a somewhat linked list based approach. So we start at 0th index and we get 2. Then we go to second index. Okay, then we find 9. Then we go at ninth index, we get 7. At 7th index, we get 5. Fifth index, we get 3. Third index, we get 6. Sixth index, we get 1. First index we get 4, and at fourth index we again get 9, and this becomes the duplicate number. So basically over here this was the starting point of the cycle. In this scenario, the starting point of the cycle is basically the duplicate element. Now how to get here is the question, right? So both stop and slow and fast pointer, both of them start from here, but how would they reach here? So again, we'll we'll move slow and fast pointer and wait for their first collision. As we know, as we have seen that the slow and fast pointers are starting one step earlier than the cycle initiation point. So their first collision would be one step behind this point of collision, which is point 4. So S comma F would meet here. You can manually, do this exercise and you will get to know that S comma F will have first collision at this point. All right. So we know that this distance, which is the distance from the first collision point to the cycle initiation point, this distance would be equal to the distance from where S comma F started at the first place. So what we'll do is, once the collision point is known, then we'll take one of the pointers and place them at the starting location. All right, and then we move both the pointers, slow pointer and the fast pointer, one step at a time. And at the second collision of the slow and the fast pointer, we'll get the duplicate element. So this is the approach. Let's see how is the implementation. So we don't need any linked list for that. We can just simply do it. So n is not required. So let's remove it. So we start from the starting of the array and we find the first collision. So first collision, what we'll do is we'll just calculate the next step for the slow and the next step for the fast, right? And check if they both of them are equal. So until both of them are equal, we'll keep on doing and find the first collision. Once first collision is known, we'll take the one of these pointers and place them again at the starting point, right? And again, once like again until they are equal, we'll increment them one step at a time. And once they are equal, we can return any one of the pointer, and that would be the solution. So let's see how does our solution looks like. So as you can see, I have printed uh, the first collision point as well, which is this. So as I had shown here also that this would turn out to be the first collision point, and the 9, which is a duplicate element, turns out to be the answer. So over here, time complexity is O of n, which is the best of the two approaches we have discussed earlier. But the space complexity is O of 1, which is again the best of the two approaches that we have discussed earlier. So this turns out to be the best approach for solving this duplicate number problem, right? So the lesson learned over here is that both the slow and fast pointer meets at the same point from where they have started in a directed cycle. So that's it for today. Thank you. Bye bye.